Okay, welcome to Level 1 Science Online with Henny van Vieren.
Hi there, Year 11s. Thank you so much for joining the meeting this morning. I really appreciate it. We went through pressure. I just thought I'd do a quick recap. So, just for the success criteria, you can see here that we are going to be defining the term pressure and also then use the relationship of that. Okay, I told you about the song from Queen. Yep, so that's Queen's song Under Pressure, but go and have a look. So, pressure, the relationship of pressure is the what do you call it, the force over the surface area. Okay, so the bigger the force and the smaller the surface area, the bigger your pressure is. The smaller your force, the bigger your surface area, the lower the pressure will be. Okay, so in other words, if you have a very big thing that's very heavy and you don't want it to make a dent into the floor, then you put it on a very big surface area. You spread the weight, you spread the mass, but in this case it is weight force. So you've heard of that before. Spread the weight. It's like somebody lying on a bed of nails. Um, they don't get injured by the nails because their weight force is distributed over hundreds and hundreds of nails. Okay, so and here's your triangle if you needed it. So if you take pressure out, you have P equals F over A. So over here equals F over A, the force over the surface area. The reason why this pin is not hurting him in his finger is because he's got a broad surface area there where it's a very fine surface area at the bottom. Now remember, if it's expressed in centimeters squared, your area always has to be meters squared. So if it's in centimeters squared, please divide by 10,000. Okay, you have to divide by 10,000 to take from centimeter squared to meter squared. Alrighty, then over here I showed you some examples of human ingenuity, how we got around to the Inuits of old, the Eskimos. They devised these shoes to spread their weight force over a bigger distance, and consequently they don't sink into the snow. Camels, you can see, has through evolution developed these really wide feet, and actually when they put them down, the feet spread out so that they don't sink into the soft sand. Whereas if you look at this deer, you can see he's got almost walking on his tippy toes, so that he can be really quiet and walk very carefully through the bush, not attracting attention from predators. Okay, and then we looked at the tractor, example of a tractor. You can see the enormous wheels on this thing. So he will work very well in a wet surface or in very soft surfaces because the surface area is really big. Even though his weight force is huge, it's spread over such a big area. Now, this next guy, it's one of my favorite examples of this. He is a Mr. Oh, I can't remember what it was, but he called it rollergons, and it's these humongous wheels. And you can see there the size of them. They're like balloons, and they spread the weight force over such a big area that the trucks could literally drive over people and it didn't hurt them. Which this is him and that is his wife. So it just shows you if you spread your weight force enough, you can actually have a low enough pressure not to hurt the person under them. Please don't try this at home. Okay, and we looked at the water skier, the example, water skier, the snow skier, the dad and his daughter, and the dad actually sank into the snow less deep than his daughter did, even though his daughter is a lot lighter than what he was. Okay, so the surface area there was zero point 0.4 meters. Okay, we also said that when there's more than one foot, or more than one leg, or more than one ski, then you need to multiply those areas. Okay, so if it's going to be a skier with two skis, you need to multiply it by 2. If it's a chair with 4 feet, you need to multiply the area by 4. Okay, So we took this as an example, but I think we can do it on the next one. So here we go. Question 1. The chair of 15 kilograms has 4 legs in contact with the floor. Um, so the mass is 15 for the chair, the mass is 15 for the footstool. And you can see the footstool in comparison has got a very big surface area that it's resting on. So that means that the weight force of that footstool is being spread more evenly, and consequently the pressure is a lot less. But we'll get to that in the second part. So the area of each leg in contact with the floor of the chair is 0.01. So calculate the pressure that the chair with a mass of 15 kilograms exerts on the carpet. In your answer, you must determine the area of the chair leg in contact with the floor, the weight force of the chair, and the pressure acting on the carpet. So let's do the first thing. So area, weight force, and pressure. First time, there's 4 of them, so we say 4 times 0.001 meters squared equals 0.004 meters squared. Okay, so that's easy. The second one is the weight force. So weight force, we say Fw equals M, and usually it's Ma, but in this case, because it's weight force, it is gravity, so Mg, and we know that that is 10. So we take mass, which is 15 kilograms, and it always has to be in kilograms, multiplied by 10 meters per second squared. And that gives us 150 Newton. Okay, so now we have F. Consequently, after that, we can then go say pressure equals force over area. So the weight force over the area, which is 150, divided by 0.04 meters squared, and this is Newton, and that is going to give us a certain amount. Divided, no. So 150 divided by 0.00 04 equals. So we are talking about 3,750 Pascal. So we figured out that that is correct. Oh, see, I made an error. I actually only said 0.04, not 0.004. But anyways, you get what I'm going at. Then the person sat on the chair and then sat on the footstool for the same period of time. They noticed that the chair legs left deeper marks in the carpet, and we know that that is because of the increased surface area. So explain this in terms of pressure, force, and surface area. So your force is the mass. Mass and downward acceleration plays a big role. So, but both of these have the same downward force. And you know that because they're both 15 kilograms. Okay, which makes it 150 Newton. So if both of them have the same force, why then the difference in pressure? And the reason for that is that pressure is force over area. And as the area increases, when your, what's this, the numerator, or when the one under the line increases, it becomes a smaller and smaller and smaller number. It's like 1 over 2 is a half, and 1 over 100, so 1 over 2 is 50%, and 1 over 100 is 1%. So the bigger this one becomes, the smaller the number. Okay, so please keep that in mind. So consequently, because the surface area is so much bigger, you then have less pressure being exerted on the carpet. So the footstool has a much larger surface area in contact with the floor, and the force applied to both chair and the footstool are the same because the same person sits on both. So P equals F times A, or F divided by A. So if the area is bigger, then the pressure must be smaller. I don't like this question at all. Okay, so a family decides to spend a day at the snow. This is the one with the snowboard. Um, so the father hires a snowboard for himself and a pair of skis for his daughter. Assume the snowboard and the skis are rectangular in shape. The father and snowboard have a combined mass of 80. Calculate the pressure exerted by the father and snowboard on the snow. So earlier we saw that the snowboard's surface area is, what was it, 0.4? I think it was 0.4. Yeah, 0.4 meters squared. So his weight force is mass times gravity, which is 80 times 10, which gives us 800 Newton. And then pressure equals force over area, and the force in this case is 800 Newton divided by the area, which is 0.4 meters squared. And that gives us a certain answer. Okay. Okay, so it was 2 kilopascal. Remember, kilo is simply 1,000, so 2 Pascal, 2 kilopascal. And Pascal, the unit is PA. So the father notices that his daughter on her skis has sunk further into the snow than he has on his snowboard. The father and snowboard has a combined mass of 80. The daughter and her skis have a combined mass of 58. Explain why the daughter and her skis sink further into the snow than her father on his snowboard. In your answer, calculate the pressure exerted by the daughter and her skis on the snow. Compare the pressure exerted by the father and the daughter. So remember that the dad. So dad was 2,000 Pascal, and now we need to do the daughter. Okay, so just quickly back up. So in the original, it gave us the dimensions of the daughter's one. So you can see here that sinking depends on pressure. The greater the pressure, the further the person will sink in. The pressure is force over area. The lighter person will have less mass and less weight force than a heavier person. However, the lighter person force is spread over a much smaller surface area. It can produce higher pressure than the heavier person. In this example, the skis have a much smaller surface area than the snowboard, so the daughter sinks further into the snow. So the dad, we said, is 2,000 Pascal. The daughter, her weight force is 58 kilograms multiplied by 10 meters per second gives us 580 Newton. Now, the area of the daughter, there were 2 skis, so 2 times, and it was 0.08 multiplied by 1.75 gives me that. So your pressure of the daughter is force over an area is 580 divided by 0.28 gives us 2071 Pascal. So the daughter sinks further into the snow. Okay, we also looked at the horse, and he had a surface area of 44 square centimeters. You divide that by 10,000, then it gives you the meter squared. And sinks in the sand when the horse stops. The hooves exert a pressure of that amount. Calculate the weight of the horse. So the weight force of the horse is going to be a function of F equals m times g. Do we have F at this stage? No, we don't. Do we have G? Yes, we have G. So how can we get F? They give us the pressure, and we know pressure is F over area. So I've got the area and I've got the pressure. That means I can very easily get my weight force. Okay, So now the main thing here that you need to see is each of the horse's hooves has a surface area of that. So your area is going to be 0.0044 meter squared multiplied by 4 because the animal has 4 legs, and that is 0.0176 meters squared. Okay, and then we need to rearrange this. So we're going to have a triangle, and we'll put F at the top and P and A. So if I want F, then it's going to be P times A. F equals pressure times area, and that is, the pressure is 200,155 Pascal multiplied by 0.0176 meters squared, and that gives us a certain number which I'm not going to work out now. We'll see what the model answer says. So yeah, there it is. Okay, and you can see there. Now they said when a rider walks next to the horse sinks in a certain amount, and then the rider gets on. So it's exactly the same as the other questions. And you need to say that the mass increases of this whole system, and because the mass increases, the weight force increases. And if the weight force increases, it increases the pressure. And if the pressure increases, it sinks further into the soft sand. And you have to just use those words, and you have to explain it along the equation. Remember, they give you this equation, so it's not even that difficult. Okay, and then in 2017 they looked at the waka ama. Waka ama is an outrigger waka, as used by the Maori. The sketch of the waka ama hole is shown below. Okay, now calculate the pressure exerted by the waka ama, both holes, on the water. Your answer should include an area calculation. Assume both the waka ama holes are rectangular in shape, and the measurements shown above show the area in contact with the water. The calculation of the pressure. So first thing we're going to do is do the area. So if we look at the main area of the waka, it's going to be 0.4 times 6.55. So it is 0.4 meters multiplied by 6.55 meters plus the outrigger, which is 0.15 meters multiplied multiplied by 4 meters. Okay, that's going to be our area, and if I put that into my trusty calculator, I get 4 times 0.15 equals, so area is at this stage plus 0.6 meters squared. Alrighty, and the other one is 0.4 multiplied by 6.55 equals 2.62 meters squared. So 2.62 plus 0.6 gives us 3.22 meters squared. So there we have the area. Now, pressure is force over area, weight force over area, and they've given us the weight force. So we can now say that the weight force, well, they've given us the mass. Now remember, weight force is F, oh, that doesn't work there, F equals M times G, so that means that it's 9.9 multiplied by 10, which gives us 99 Newton. So we have 99 Newton divided by 3.22. Okay, so 99 divided by 3.22 gives me 30.1 basically Pascal. Wow, that is a really low pressure being exerted, and that's why it floats so well. Okay. Okay, there we go. There's the model answer, same as mine. So you have to remember to add the two surface areas together, just like you would add four legs together. This is just two boats, basically. And then you calculate the mass, which is 99, and you get to 31 Pascal. Okay, question 2. The waka armor sinks further into the water when a paddler, a 67 kilogram paddler, sits in it. Explain why the waka armor sinks further into the water when the paddler sits in it. Use calculations to support your answer. Okie dokie. So, first thing is weight force for the waka. So the waka is, the weight force is 99 Newton. Okay. We have to add that to the weight force of this paddler. So if we take 67 kilograms plus 9.9 kilograms, that gives us 60 or 76.9 kilograms. Okay, so then we say F equals M times G, and G we know in this case is 10, and the mass is now 76.9. So 76.9 kilograms multiplied by 10 meters per second squared, and that gives us 769 Newton. The pressure is now significantly higher because remember, pressure is all about the relationship between the force and the area. So now the area stays the same, which was 3.22, if I'm not mistaken. Let's just quickly go one back up. Yeah, so the area was 3.22, so the below the line remains 3.22, but above the line went from 99 Newton up to 769 Newton, which is a lot higher. And that gives us a pressure calculation of
238.8 Pascal.
Okay, so in your explanation then, because we're explaining, you will then explain that because the pressure went up, because the mass went up, the pressure went up, and because the pressure went up, when the mass went up, the force went up, and if the force goes up, the pressure goes up, but the area remained the same. So hence, the pressure is now a lot higher. So let's look at the model answer. So sinking depends on pressure. The greater the pressure, the further the waka armor sinks. So pressure is force divided by area. A heavier waka armor with a person in it will have more weight force than a lighter person. The weight in total after will be weight force total equals mass times gravity. Yeah, we did that, 769. In this example, the waka armor has more weight force with the person in it, so the waka armor sinks further. For example, comparing the pressure of the waka armor, we said before it was
30.7,
and with the person in it, it is
238.8 Pascal.
alrighty. And that is where we will conclude. I will put some site information for you on the web, on the OLE. Okay, thanks a lot. Have a great day. Bye.